Welcome guys to the math series. This is another amazing series and this is our topic 2 in the math series. I hope you guys enjoyed the first series. So today we'll be talking about the basic arithmetic. In our first series, we talked about introduction to numbers and many people enjoyed it. So today, let's look about how we add, subtract, multiply and divide numbers. So let's begin. Now talking about the basic arithmetics, we all know that we have 4 basic operations or operators in mathematics. And talking about that, we have the addition, which symbol is what? Plus. We have the subtraction, which symbol is this? We have, this is minus, we have the division or the multiplication first. Times, and we also have the division. Divide. So these are the 4 basic operators we have in mathematics. And talking about the basic arithmetic, these are the 4 basic arithmetics that we play with day by day and time to time. In any sector of the world you must need this. Even as a student, as an engineer, as a doctor, this is very important. But let's kickstart fully. Now, I want to talk about addition. What comes to your mind when we talk about addition? Now, adding 2 numbers gives you the sum. Adding 2 numbers gives you the sum. So when you do addition, the result is what? The sum. And subtraction. Subtracting 2 numbers or more. Let me go back. In addition, adding 2 or more numbers gives you their sum. Subtraction. Subtracting 2 or more numbers gives you their difference. Then multiplication. Multiplying 2 or more numbers gives you what? Their products. Then we go to division. Dividing 2 or more numbers gives you what? Their quotients. Their quotients. So I want you to enjoy this series because this is really amazing. It's been a while I did the simple plus and minus. So I want us to enjoy this together. So let's go. Now let's start from addition. Let's give some pretty examples of addition. So talking about addition, let me use 2 persons as an example, Bola and Kemi. If Bola has 3 cakes, and Kemi has 7 cakes. So, adding Bola cakes and Kemi's cake, we have 1, 2, 3, and Kemi 1, 2, 3, 4, 5, 6, 7. So this is just my symbol for the cake. Please accept these sticks as my symbol for the cake. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the sum of Bola's cake and Kemi's cake is what? A total of what? 10 cakes. Hope you're understanding it. Now let's assume that an extra person called Edidion. Let's say Edidion then has 5 cakes. So adding Edidion's 5 cakes, we have 1, 2, 3, 4, and 5 cakes. Bola 3 cakes, Kemi 7 cakes, and Edidion's 5 cakes. Don't forget that the sum of Bola's cake and Kemi's cake was giving us what? 10. And now adding Edidion's cake, which is 5. So from 10, we start counting now from 11, 12, 13, 14, and 15. So now it means the sum of Bola's cake, Kemi's cake, and Edidion's cake is giving us a total of what? 15. This is just like one of the basic concepts of addition. One of the basic concepts of addition. Now, when I was learning statistics back then in school, we call this tally. But now I'm now using them as what? Cakes. So understand them in my own concepts. So this is just one of the basic steps of addition. Now, for parents that their children are finding it difficult to add and subtract, I urge you to teach your child how to count with my cakes. How to count with my cakes, 1, 2, 3, just drop my cakes if they are having 10 cakes. And also they are having 21 cakes. And the child does not know the sum of the 10 and the 21. Just tell him, okay, draw the cakes, draw 10 cake, draw 21 cake, count all together, it will give you the sum. And I think that's the best way. But in a situation whereby you are having a large number, then I will show you a simpler way of approaching that when we are talking about place value. So now, aside from the addition, let's also look at the subtraction. Now let's use Kemi and Edidion. Now let's say both Bola's cake was given to Kemi, and now Kemi is having a total of 10 cakes. Kemi now is now having 10 cakes, and Edidion still has 5 cakes. So now, we want to see this. Now let's remove 5 cakes from Kemi and give to a new person called Victor. Now I want to take Kemi's 10 cake. Out of his 10 cake, I want to take 5 of those cake and give to a new person called what? Victor. What I will do is that I will subtract 5 of the cake from 10 of his cake. Now, for those that don't know how to subtract, still use my cake concept diagram, which is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are Kemi's 10 cake. So let's take out 5 from Kemi's cake and give to what? Victor. So yeah, we'll be having what? 1, 2, 3, 4, and 5. So we have taken out 5 cakes from Kemi's cake and we have given it to Victor. So now how many cakes do we have left? We have 1, 2, 3, 4, 5. This is a pretty simple concept to understand addition and subtraction. So therefore, Kemi's cake is no longer 10. Kemi then have 5 cakes. So now Kemi is having 5 cakes, Edidion is having 5 cakes, and Victor is having 5 cakes. This is the simplest approach of understanding addition and subtraction. Use the tally method, which is the normal counting, or my cake concepts. But I prefer you take it as my cake concepts. So let's enjoy the class. Now, another easy way of carrying out simple addition and subtraction will be the method of the real line. In our episode 1, topic 1 of the math series, we talked about the introduction to numbers, and I made emphasis on real numbers relating to real lines, number line, any name you choose to call it. So let's look at the real line. So when we talk about the real line, at the middle of the real line, we have what? 0. Now, to the right of 0, we have positive whole numbers, which are positive integers. We have here 1, 2, 3, 4, and what? 5. And it still runs down to what? Positive infinity. So to the left of 0, we have negative whole numbers. -1, -2, -3, -4, and -5. And this runs down to what? Negative infinity. Not because I'm saying to the right of 0, we are having positive whole number. You can correct that word. Not just positive whole number, but we are having positive values. Because in between 0 and 1, we still have other values. Talking about 0.1. 0.1 is still fine in between 0 and 1. Talking about 2.674 is still found in between 2 and 3. So you can correct these statements, positive whole numbers. Let's go with what? Positive values. And to the left, we have negative values. So now let's go. Now, my major reason of emphasizing on the real line is because I want to show you another trick in addition and subtraction. Now, most people don't know how to solve a question like this. -5 plus 2. Most people don't know how to solve a question like this. And I have encountered them severally. And I say, oh, what do I do? Now, this is what I'll do. I will explain the concept of solving a question like this using the real line. Meanwhile, you can still solve your normal addition and subtraction. If it's positive to positive, negative to negative, can still solve all of them here, like using your tally method and also using your real-line method. But now in this concept, we are having negative 5 plus 2. Note this about the real line. Now, if a number is being added, in the real line, the counting of addition goes to the what? Right. In the real line, the counting of addition goes to the right. While subtraction counts to the what? Left. Addition counts to the right and subtraction counts to the left. Now we are having minus 5 plus 2. It means that the first value there is a negative value. And here we are lucky to have minus 5 in our real line. So this is it. Minus 5. I gave it tick sign here. So now we are asked to add 2 to minus 5. So don't forget that if we are adding in the real line, we must count to the what? Right. So for minus 5, we go 1 and 2. So we are adding 2 to minus 5. Counting 2 from minus 5 to the right gives us what? Minus 3. So the value of minus 5 plus 2 is what? Minus 3. But I can tell you that most people don't know without calculator that the value of minus 5 plus 2 is what? Minus 3. That is why MathTech is here to help you. So enjoy the series. Let's go on. And most people, I've been in a situation where someone has been asked, minus 3, minus 3, minus 3, minus 3. How? Most people find answering a question like this difficult. Once you say a question like this, the first concept that should come to your mind should be your real line. The first concept that should come to your mind should be your real line. So this is our real line. Having this diagram here to be our real line. And look out for minus 3 at the left. And since we are subtracting 3 from minus 3, it means that our counting should go to the left. Let me extend my line. Let me extend my line if I add my infinity so that we can get the correct answer. So here will be minus 6. Let's see, here should be minus 7. And we see here to be minus infinity. So now let's do our counting from minus 3. This is minus 3. So we are asked to subtract 3 from minus 3. So this counting now goes to the what? Left. So we go 1, 2, and 3. So the difference of minus 3 and minus 3 is what? Minus 6. Guys, this is pretty simple. This is pretty simple. You just have to know which of the methods should I use to get the answer. Most times you don't really need calculators. We just need to know some physical methods that we can apply to get our answers correctly. And I believe you're enjoying this. What if we have something like 1 minus 6? Most people don't know the value or the difference of 1 and 6. Most people say, 1 cannot minus 6. 6 is greater than 1. How is 1 minus 6? But when you are applying the method from your real line, you get the results. So let's do with that now. So for 1 minus 6, don't forget our 1 is positive. Since there's no negative value attached to this one, it means the 1 is positive. And we can find the positive 1 at the right side of what? 0. So this is it. We take here, positive 1. And we are asked to subtract 6 from positive 1. Since we are subtracting, our counting goes to the what? Left. So we go 1, 2, 3, 4, 5, and 6. So the result of 1 minus 6 is what? Minus 5. I'm so happy. It's been a while I saw something like this, and I'm very happy that I'm doing this today. This is really interesting, guys. So hope we are enjoying this particular series because this is the foundation of mathematics. This is where many people face challenges, but I'm here to clarify you on that. So let's say we've successfully touched the cake concept method, counting with tallies, and we have successfully touched the number line method. Now, you can also extend your number line. You can make your right hand run down to 20 before it goes to infinity. You can also make your left hand run down to minus 20 before it goes to minus infinity. So, depending on how you want to extend your number line. But when solving more greater values, like high values like 200 and 300, and you will not use the concept of number line. Neither will you use the concept of tally, which is our cake concept. So now, before we go to the concept we'll be using to be solving more complex values, let's first of all touch the addition, the multiplication and the division before we get there. So now, talking about the multiplication, this is it. Let me not use Kemi, Edidio, and Victor. Let me just use a direct approach. Now, we are given 3 times 7. But I'll still apply my cake concepts. Let's say we are using 3 cakes. Let's say we have 3 cakes and we have to multiply that 3 cakes by 7. So, these are 3 cakes. We have to multiply these 3 cakes by 7. So, we have another 3. We have another 3. Another 3, another 3, another 3. This is 1, 2, 3, 4, 5, 6. So the last one. So if you are multiplying these 3 cakes by 7, then how many cakes are we going to have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So this concept of multiplication is very simple. Now, I want us to just understand the foundation. I'm very concerned in you understanding the foundational aspects of solving mathematics before we then go to the professional aspect of solving it. We are asked to multiply 3 by 7. What you do is just, you draw 3 cakes 7 times. Then you count all of them. That gives you the product of 3 and 7, which is 21. Now, let's look at 5 times 6. So let's count 5 cakes into 6 places. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And here we'll be having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Now, without your calculator or your times table, we know that 5 times 6 without calculator or times table is what? 30. Using what? The cake concept or the tally method. But don't forget to always appreciate the cake concepts. Now, I will urge you parents or anyone that is finding these basic stuff in mathematics a bit difficult. Parents, I will advise you to ensure that your children works with the timetable. Talking about, let me just recite the 5 times table. 5 times 1, 5, 5 times 2, 10, 5 times 3, 15, 5 times 4, 20, 5 times 5, 25. All those practices will also help you. Even the 2 times table, the 3 times table, the 4 times table, 5 times, 6 times, 7 times, 8 times. So all those, the times table will help you also in understanding your multiplication. And one thing that is very good this period is that our exercise books contains the times table at the back. So you can give your child to go on practicing it time to time to also help your child's understanding about multiplication. So this is just the simplest concept to show you under multiplication using the tally method. But when it is a more complex value, how do we go about it? I'll show you that still in this video. So let's go to division. Division is a kind of tricky for most people, I'll tell you. You know why? Because having a number, an odd and an even number, I'll not really go deep into explaining an odd and an even number. But when you have an odd number is a number that when divided by 2 has a remainder. But an even number is a number that when it is divided by 2, it has no remainder. So, when you have an odd number dividing an even number, there is certainly going to be a remainder. But I will still show you the concept of handling division that gives you a result without remainder and that gives you a result with remainder. Let me give an example for the division. Let's say we are given a value 20 divided by 2. Now, I will still use the tally method to explain this division concept. 20 divided by 2. So I will count 20 cakes. the cake concepts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Now we are asked to divide 2 from 20. So how do we do this now? This is how you go about this. You just say 1, 2, you add them together. 1, 2, add them together. 1, 2, make them 1. Now making all of this, each 2's 1. Then gives us how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Wow! This is pretty interesting. My cake concept is so amazing, and I'm happy I did it. So let's go further. Let's say we are giving 20 divide 3. Oh! Dividing an even number. Using an even number or using an odd number to be divided by an even number. Let's see how it goes, if we will have a remainder or not. But one thing about the cake concept is that it will help us to know the remainders when we divide. So we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we are asked to divide 3. You know how we do the counting. We count 1, 2, 3, they become 1. 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 And here we're having just 1, 2. So it's not up to 3. So this is what do we do now? We say 1, 2, 3, 4, 5, 6. So the result of 20 divided by 3 is what? 6 remainder 2. Wow, this is amazing. But these are just for simple values. What if we are now approaching a more complex values? We will do that right here. Now, another approach to get the value of this is, the value of 20 divided by 2 is, look at this. We say 20 all over 2. And this is another concept of following division. Now, 2 divided 2 will give you what? 1. 2 into 2 gives us 1. And here we have 0. Just write down the 0. And we are having 10. Now let's look for 20 divided by 3. 20 divided by 3. This cannot divide, so this approach is the best to follow up, and lots more. Try to practice with the cake concepts or tally method. Also practice with this normal division method. So now, let's enter the world of dealing with more complex values. More complex, like large values. Now, I'll be introducing a new concept to us. So now, dealing with the large values or the complex values, as I stated earlier, it leads us to understanding place values. But guess what? When you spend too much time learning, it might get boring. So let's take a break. Watch out for the next episode. You'll get the results, and you will learn everything about place values and other subtopics under basic arithmetics. Thank you so much. Don't fail to like, share, comment, and subscribe. And please, if you have any challenge in one way or the other, drop your questions at the comment section. I'm here to give you the answers. Thank you.